Hi guys, how is it going? Welcome back to A4 Analysis. As you can see that I still haven't come up with a good intro for my channel, but I still have managed to get back with an interesting dataset. This time I have a dataset for shared bike demand analysis. So last time in the case study, we tried to do exploratory data analysis uh, to understand who are the people who are going to default the loan. And today we are going to predict the shared bike analysis. Now let's try to understand the problem statement first. So there is a company which provides a bike sharing facility, like they can rent bikes for some time temporarily, and people can use those bikes and give those back. So now when there is a question of renting these bikes, so they have to provide these bikes and they really need to understand where the demand is more, or when exactly through in the year, when exactly the bike demand goes up and when exactly the demand is not so much. So after understanding that, they can make certain business decisions which will impact their revenue so much in the positive way. So first of all, they need to understand what are the important factors responsible for boosting the bike demand and what are the times when the bike demand is not so much. So as a data analytics, our goal is to do demand. We have to predict the demand with the help of regression tools. So first we'll look at the data and we'll go ahead with the analysis. So whenever I do the analysis, I first write down the approach. Most of the time I have a basic idea what things I need to do, and once I start working on the dataset, after that sometimes I make few changes in the course of action, and finally once it is done, then I just rectify the first uh, map that I made for myself, and that is what I keep at the first of any dataset analysis. So first let us go through the approach and then I will also walk you through my code. So first thing first, we'll import the modules and we'll read the dataset. Then we are going to deal with the categorical data, if there is any encoding required, if there is any univariate, bivariate analysis possible, visualization possible, we'll do that. And we'll also drop the columns if applicable. Next, we are going to deal with the numerical data. We'll check the statistical summary, like with the describe method, if you know. And we will also do univariate, bivariate analysis. We'll visualize the data and we'll also do outlier detection. Of course, it's not possible for the categorical data. This is only applicable for numeric ones. And we will drop some columns if necessary. We'll do the train, test, dataset splitting, and we'll scale the data, scale the features actually, and then we have to do some feature selection and we have to build a model. Now for feature selection here, exclusively we have used RFE and VIF and p-value method, because till now so far for this assignment we were not allowed to use feature selection tools like PC and stuff like that. So we had to go with RFE and VIF for now. So finally, once we are ready with the final set of features, then we have built the final model, and we also did a very important thing, which is validating the linear regression assumptions, whether at all it was the correct decision to apply linear regression. That is what we have validated after building the dataset and everything. And yeah, of course, I'll show you how each and every assumption I have validated here. and also we have predicted the target variable, which is of course the bike demand here, and we have also evaluated the model. Now let's jump into the code here. As you can see here, first I have imported the modules, just reading the first few rows of the dataset. I am checking the info column. So whenever we are running this info command, we can see in a quick look that there are most of the things in integer values or float values. We have only DTE day, I think this is date day, as an object. Rest of the things are integer. Now few of the things must have been in object, but they are not, like this month, and maybe few other things should have been, but they are not. So this is my observation from the first look, from the first few rows of the data and the info command, that the data set doesn't have any missing value, which is a really good thing. We don't have to do a missing data handling. Then there is instant column, which is a unique identifier column, so we can set it as an index. Then we got year, month, date. This we can extract from the DTE day. After DTE day, month, year columns can be dropped. So what I am telling here is this one, this particular DTE day, we can go back and see here. Basically this is giving me the date. So instead of using date, because with date we cannot really do anything, right? So in order to understand any trend, if at all there is any trend with respect to the day, with respect to the month, or with respect to the year, we have to extract the date of the month and the year out of this DT day or date day or whatever you want to call this. And after that, once we have extracted that information, we can drop the redundant columns. That's what I am telling here. Next we got season, weather sheet, weekday. These guys are having 1, 2, 3 values like this. So we cannot really make sense out of 1, 2, 3. For visualization purpose, we will use better names so that it is more readable, more understandable. And next we have categorical features like holiday, working day are already labeled as 0 and 1. So it's already like a switch. So we really don't need to do anything about it. But if we have 1, 2, 3 values like that, and if we are trying to do a linear regression on top of that, it will be a very bad situation, because these values, these are really not ordinal categorical variables, so we have to represent them as 0 and 1 only. Next we have the actual numerical columns. Those are temp, atemp, humidity, this is hum, and there is wind speed, casual, registered, CNT, these things. Next, so here I have just made it as index, which is fine. Then extracting the date, month and year like this. I have used date time index module from pandas, which is very useful to do such kind of things. It will directly give me the day, month name. I could also use month, which will give me 1, 2, 3, which is again the same thing. So here I particularly wanted January, February like that. That's why I've used month name. And last but not the least, I have used year, which will extract the year and put it in here. Next thing that I did is I just dropped the redundant rows, not rows, columns. And after that, I'm checking the info again. Next thing I'm doing is I'm checking out the weekday feature, and out of weekday I'm also checking the working day. So why did I do this exactly? This is because the weekday is given in numbers like 0, 1, 2, 3. Now my doubt was whether 0 is Monday or 0 is Sunday, because in some cases Monday is considered to be the first day of the week. In other cases, Sunday is considered to be the first day of the week. So I was not really sure about it. That's why I just wanted to check with respect to weekday, what are the working days. And as you can see, for 0 here, working day is 0, and for 6, working day is 0. And for 1 to 5, we have all the working days. This is the count of working days actually. So from this, we can say that probably this is Sunday, and this 0 is Sunday, and 6 is Saturday. Next we got season, and in season as well there is 1, 2, 3, 4 given. This was given in the data dictionary that 1 means spring, 2 means summer, 3 means fall, 4 means winter. But when we are doing a data visualization and in our graphs we can just see 1, 2, 3, 4, it will not make good sense, right? So we wanted to make it more interpretable. That's why we just made it to its actual values, which is spring, summer, fall, winter. For season, for weather sheet, there is clear or partly cloudy, mist and cloudy, light snow or rain, heavy snow or rain, things like that. And for weekdays as well, as we already confirmed here, 0 will be Sunday, 1 will be Monday, and so on. So like that, we have changed these columns to their categorical values again. Next thing that I did is the visualization, of course, because once we have got these string values, now it is very easy to like visualize this data. Now as you can see here, we have did a shared bike demand analysis. Like we are checking the bike demand based on the seasons. As you can see here, for fall season the bike demand is like the highest, and for spring it's the lowest. Whether in contrast to fall and spring, in summer it is in the middle, and in winter as well. Similarly, you can see that for weather sheet, when it's clear or partly cloudy, the demand is most, and when it's mist and cloudy, the demand is quite less, and when it is light snowy or rainy, then the demand is very, very low. And there is actually another weather sheet value for which I think that is like heavy snow or heavy rain, which I already encoded here, but there is no value at all, which means that when the weather sheet is heavy snow or rain, nobody is renting these bikes, which makes complete sense, because in such a weather it is not very convenient to use a bike like that, right? So probably people are using cabs during that time. That's what I have written here. People are most likely to rent bikes in fall and least likely to rent the bikes in spring. Highest demand of shared bikes are seen in clear or partly cloudy weather, and light snow or rain results in low bike demand, and there is no bike demand in heavy snow or rain. Next thing is done for the day, month, weekday, and for the year. So as you can remember that we have extracted the date, month, and year out of the date day feature, and also we have an independent feature of weekday. So what is the trend we can see for the shared bike demand with respect to the date? There is nothing much of a like trend going on here, because as you can see, slightly higher demand during this 4th, 5th, 7th during this time, and the demand is quite low at the beginning of the month, and it kind of stayed same throughout the month. That's what I can see here. When it comes to the year-wise trend, as you can see that in 2019, the demand was quite higher than 2018. So if at all we have to give some intuition from here, we can say that next year probably it's going to be even more. So that's one thing here. Next, we can see that year-wise that for this couple of months, the demand is quite high. Next, we'll do further analysis on the months, but from 1 to 12 or January to December, there is clearly some trend going on here. And as you can see for the weekdays, it looks almost the same, but definitely we can infer some information from here as well. Just reading out from here a little bit, dates between 5 to 8 have shown comparatively higher demand. Might be because of holidays, but this is not entirely a fact that 5 to 7 or 8 definitely has some holidays or something like that. And even from business perspective, you cannot really tell that, okay, there is something going on between 5th and 8th, right? Because of course people are going out when they are free or when the weather is really good, things like that. It definitely doesn't matter what date it is, right? But definitely we can talk about the year that demand of the shared bikes have increased a lot in 2019 in comparison to the previous year. Then we also talked about this November, December, January and February are the months having comparatively less demand than other months, and highest number of bike rent in a day is higher on Saturday, Sunday than weekdays. Of course, people are like spending holidays, probably going outside or something like that, and maybe because of that they are renting more bikes on Saturdays and Sundays in comparison to the other days. Next, we also checked out what is the bike demand on holidays, on non-holidays, and on working days and non-working days. So 0 is the non-working day, or what we can call as holiday, and 1 is the working day. Similarly here 1 means holiday and 0 means it's not a holiday, it's a working day. And definitely there is some difference. It's not exactly like opposite of each other. There is a difference in these two. What is the inference that I got from this? That is, bike demand is very similar whether it's a working day or not. Working day has slightly less demand. The lowest number of bike rents is higher on holidays than that of non-holidays, and the highest number of bike rents is higher on non-holidays than that of holidays. So I'll just show what I meant here. See here, the upper bound is quite higher on non-holidays. That's what I'm saying here, that when it's not a holiday, the highest number of bike count is somewhat more. Next, we also check the monthly trend. Again, this time around we tried to like sort the months with respect to the bike demand, and after that, since we have 12 months and we cannot just create 12 new columns for those 12 months, what I have thought to do is we will group the months together, probably 3 months in a group. So we'll have 4 groups, and even out of 4 groups we can take just 3 groups to avoid dummy variable trap. And with the help of these 3 groups we will be able to represent all our 12 months. And also when we are taking the similar value, the months having similar trend together, so even if it is taking the average value, it will not be a huge mistake. The error will be quite less. But if you take, suppose if you take half months in a group and half in other one, so you will see that for in comparison to this one is quite high, so there will be, the error will be more, or it will be better seen in this one. As you can see here, the change is quite high. So if we are taking even average of this, for these 3 months it will be overestimated, and for these 3 months it will be underestimated, like that. So once we are taking small groups, the error will be quite less. That's what I have explained here that I am going to take 3 groups here, and the 4th group we are not taking separately. It will be already represented by the first 3 groups. So the first group is July, August and September, having highest bike demand. Next group is this one. The third one is March, April and November. So it's basically not in the order how the months appear in the year. Rather than that, it's the group is formed with respect to the demand of the bikes, right? So the months having a similar bike demand are grouped together. So that's what I have done here. I just created 3 new features with these names, and 0 means the month is either July, August or September. 1 means this month is okay. So 1 means I just told it completely wrong. 1 means the month is either July, August or September, and 0 means anything else apart from that. Similarly, other features are implying the same as well. Next thing, I created the dummy variables. After that, I moved on with the numeric data. And first thing I want to do all the time, that is, if the features are quite less, then it is even easier to do, that is checking the pair plot. Pair plot gives a summary of the relationship between the numeric variables, as you can see. So diagonally we will have distribution, right? And in all other blocks we will be having a scatter plot. Okay, so as you can see here, there is a very strong, really strong linear relationship between atemp and temp. This is because temp and atemp, one is actual temperature and the other one is the temperature that is being felt. And for few other features, you can see that there is somewhat a linear relationship going on. I scroll down a little bit. As you can see, even for this one, there is a very strong linear relationship going on here. For count, this count is the total number of bikes rented on that day, and registered is how many registered users rented bike, and casual means probably these users are not yet registered, they probably did it for once, something like that. So this plus this, casual plus registered bike rents equals to the total number of bike rents. That's what I got after that. So after checking the pair plot, again I just checked out the correlation as well, and of course it's telling the same fact that temp and atemp has very high linear relationship, and like 0.99, which means like they are almost the same thing, and a count, this registered column looks very linear as well. And if you take a close look, you will see that casual plus registered equal to count. So what I wanted to do is there any column which doesn't hold this relation, and you can see that there is no row at all which doesn't hold this true. So we are confirmed that these 2 columns are making the count column, and since count is the dependent variable here, we don't really need this casual and registered anymore, because we know that these are part of the dependent variable. So keeping that in our model will not help anything. That's why we thought of dropping it. Next thing we did is checking out the distribution. So as you can see here, temp and atemp have very similar distribution. Humidity is most likely to be in between 50 and 100, and then we have wind speed, mostly commonly seen between 8 to 12. 8 to 12, this is the highest peak. I just check the peaks and whether it's skewed or not. So registered and count have very similar distribution, of course, because this two summation is this one. So again, this value is quite high in comparison to casual. Registered users rent is quite like registered users number is quite higher than casual users. So whenever these two are added together, the distribution will be similar to the larger number, which is the registered user. That's what we can see from this. Next, we are checking for the outliers. Of course, there are some outliers, but we are not going to deal with the outliers of the dependent variable, right? For wind speed and casual, we can see some outliers, and for wind speed, since it's a predictor and casual is a directly related to count, which is casual plus register equal to count, we will consider 99 percentile for both. So we just took 99 percentile for both. Next, what we did is scaling the data, splitting the data and scaling it. Splitting is necessary because first we want to train our model, and then there should be some data which our model hasn't seen before, and on using which we can just evaluate our model, like how good it is able to predict the demand. So that's why we wanted to split the data into test and training set, and we also needed to scale the data because all the variables have very different ranges, and we don't want to like impact the model performance because of the ranges the features are having. Next is building the model. Now, since we are not going to use any defined modules here for feature selections, we have to go with the other methods that are available. One of them is RFE, one of them is VIF. So these are the two things we are going to use to like select the features. So first, what I did here is first I built the model with all the features together, and I am checking the OLS, that is ordinary least square regression results. Now this is coming from stats model library or module, and if you are going to use linear regression from SKLearn, you are not going to get a summary like this. That's why I have used OLS here from stats model, and we are going to check this adjusted R square, which is which tells us about how much of the variance in the dependent variable being explained by our model. That's what R square and adjusted R square is. Now the difference between adjusted R square and R square is only that adjusted R square adds up a penalty term for having more features, because our business always wants as less features as possible. Now in some cases probably it will be needed to have more precision, so we will not care about how many features are there, but in most of the cases we will be focusing on as less as possible and to get a decent result, right? So here we will be looking at the adjusted R square. So first, when we are using all the features together, we are getting 81.9% variance explained by our model. And I'm also checking the VIF of variance inflation factor of all the features here.